In the previous video, I reworked part of the Bill's Burgers challenge to use an inner class, which I called item. I want you to start with that code where we left off and make the following enhancements to it. Create another inner class called burger. This should be a specialized item and should also include a list of toppings, also items. Remember, items have a name, type, price and methods to convert prices. Allow a user to add toppings using the meal class, which it should then delegate to its burger class. Allow toppings to be added with a method that allows for a variable number of strings to be entered, representing the toppings selected. Allow toppings to be priced differently, some are free, some have an additional cost. Print the toppings out along with the burger information. That's the challenge. Pause the video now and see how you go with this challenge. When you're ready, come back and we can walk through my solution together. Okay, so how'd you do? Were you able to create a second inner class on meal for a burger and add toppings, printing the toppings out itemized with the other items? I'm starting out in my nested classes project from the previous video. I have two outer classes in the dev.lpa.burger package. The first one is store, which has my main method, and meal, which is the only thing this store sells. Continuing with inner classes, I want to declare a second one on meal. This one will be called burger, and I'll add that before the closing curly brace of the meal class. Like item, this inner class is going to be private and non-static. Any access to this class and its functionality has to go through the meal class. In other words, this burger class extends item, so I don't need to include name, type or price as fields, but I do need a constructor here. Instead of generating that, I'll just add it manually and include only one argument, name. In this code, I'm simply making a call to the super constructor, which calls items constructor, passing it the name and burger as the type and $5 as the base price. Normally, when you use IntelliJ's code generation tools for generating a constructor, you get a public constructor. In this case, I'm not declaring an access modifier, meaning I'm making it package private here. As long as I don't subclass burger, this modifier's access is as restrictive as I can make it. Next, I want to change the type of my burger field on meal from item to burger. I also need to change meal's constructor because I need to instantiate a burger, not an item. Since I made burger's constructor only take one argument, I'll remove that second argument, the type burger, because that's hard-coded in burger's constructor. Notice I'm getting an error on the getTotal method in this meal class on burger.price. Burger is an inner class on meal. Why isn't its price visible to meal? Well, burger inherited that field from item, and although item's price is available to meal through the item class, it's not accessible as an inherited field on burger. The rules of inheritance are still in place even within the inner class structure. The easiest way to get around this is to create a getter on the burger class that returns super.price, so let me do that. This wouldn't work if item wasn't an inner class of meal because price is private on item, but this takes advantage of the fact that meal can access item's price. I'll change burger.price to burger.getPrice. In the getTotal method on meal. With those changes, I can run my store's main method and I should get the same results as before. But I do want to specialize the burger and add an attribute, a list of toppings. I'm going to say toppings are just instances of items. I'll use an array list. This is private on burger and I'm instantiating the list here. Before I add a method to add toppings to this list, I want to set up an enum containing the valid options for burger toppings. I'm doing this because I want to keep reviewing past skills when the opportunity presents itself. If you didn't set up an enum like this, no worries. It's just one way of many to meet the requirements of the challenge. I'll add the enum right here inside my inner class burger. I'll call it extra and add the various toppings. Note that this compiles. Prior to the JDK 16 release, this wouldn't have compiled because you couldn't include static members other than a static constant variable in an inner class. Why am I saying this is static? Well, let me add the static keyword here. Notice that IntelliJ has grayed it out. If I hover over that, it tells me that modifier static is redundant for inner enums. It's also redundant for interfaces and records. These types are all implicitly static when used as inner types. I'll just revert that change. I can also make this private, which I want to do because this enum won't be used by the client code. It's for internal use only, internal to the burger class. I want to include my add toppings method on the burger class. I'm going to make this method private, and you'll see why in just a moment. That's my method shell called add toppings. It's private and doesn't return anything, and it takes a varargs method parameter. I'll add code to loop through all the strings passed and look for a match on the enum constant by name. The value of method on the enum lets us get an enum constant by the constant's name. I take the varargs string passed on the method, making it all uppercase, then see if I can find a match to that name in my extras enum. Then I add a new topping instance to my toppings list on burger. This code is actually buggy because what happens if an item isn't found on the enum? We'll find out when we run this code, but right now let's keep going with this as is. Also notice I'm passing 0 as the price of all toppings. This isn't what I want either. In fact, in the enum video earlier in the course, I showed you an example of creating a method on your enum, and I'll do that creating a getPrice method. Before I can do that, I have to include a semicolon after my list of constants. You only need that semicolon if you're including extra code in the enum, which I'll be doing. Okay, so now I'll add a simple getPrice method. I'm making this private again, and it'll return a double. Notice I'm switching on the keyword this. When the getPrice method gets called, it will be called from an instance of one of these extra constants, so I can use this as my switch expression. For now, I've just set up the default label, returning 0 or no additional cost for a topping. But I do want to include some additional costs for avocado, bacon and cheese, so I'll add case labels for those. When you switch on an enum, you use enum constants in the case labels as I show here. I'm making avocado $1 extra and bacon and cheese will each be $1.50 extra. Going back to my add toppings method, I can call that method when I construct the topping object. I'll include a new line before the 0 in that call, and now I'll replace 0 with a call to topping.getPrice. This code compiles without issue, but are you wondering why? Why can I access a private method on the enum from this code? Again, this has to do with the special nature of inner types. Private attributes and methods are available to the enclosing class, and this is true for inner types like enums and records, as well as inner classes. I want to invoke this from a method on my meal class and just use the same signature. I'll add this method after the toString method and before the declaration of the item class. I'll call it addToppings and support passing one or more toppings. Call burger.addToppings passing the selected toppings. This method simply hands off to or delegates the work to the burger instance. Again, the meal class is able to call a private method on the burger class. Before I add any toppings in the main code, I want to make sure they get printed out, and any additional prices get added to the total price. First, on burger, I want to implement a toString method. I'll just enter this in by hand. I'm using String Builder because I'll be appending different numbers of toppings to this data, and I'll do that next with an enhanced for loop. This code adds the base price of the burgers, then each topping and its price on separate lines. Ready for printing? Now I want to go back to the burgers getPrice method. I'll remove the return super.price statement, and now I'll add the code to get the full price of the burger. I'll loop through each topping and add the price to total. What is price on this first statement anyway? Is it burger's price? Luckily, IntelliJ is keeping track for us if we get confused. Hovering over price there, you can see it's not burger's price, it's meal's base price. For the regular meal, this may be fine, but the burger's base price may change. I want to get the price off the super class, so super.price. This ultimately gets the burger's set price without the additional toppings. Okay, so I set up a local variable, total to be the burger's base price, then I loop through every topping and get the price of each topping. I can run this again from store's main method, and I should get all the same pricing as before, since I haven't yet added any toppings. But we went through all this work to add some toppings, so let's do that in the main method of store for our regular burger. Let's see if that works. You can see that the toppings are shown in this itemized list of the first burger and the total price has gone up to $10 because bacon cost an additional $1.50. I mentioned earlier that I left a bug in this code and I know exactly how to break it. I'll add a topping that's not part of our extra list, like cheddar for example. And now if I run this, I've caused my program to crash, and that's definitely not what I want to happen. This exception gets thrown from invoking the value of method on an enum for a constant name that's not in the enum. We've briefly touched on exception handling before this and learned enough to test and catch this exception. But where is a good place to catch and handle it? Do we want the code to add all the other toppings successfully and proceed with just a message that one item couldn't be included? Or do we want the entire add toppings method to fail so the clerk is forced to ask the customer again? I'm picking the first option, so I'll put a try catch block in the method that adds toppings on the burger. I'll insert a try statement before I invoke the value of method on my enum. Now I'll add the catch clause. Illegal argument exception is what I want to catch. If I end up inside the catch block, it means the topping I'm trying to add doesn't exist. Running the code again. You can see that message printed out, no topping found for cheddar, so the code handled the situation and proceeded, creating the meal with all the other valid toppings. Okay, so that was the inner class challenge. Your solution is sure to look different, and again, that's a good thing. Every developer is unique and may come up with a unique solution. I wanted to revisit enums in the context of an inner type, so I went with this particular approach to handle my toppings. Don't worry if your solution was quite different. As long as the results are the same, that's a good thing. In the next video, I'm going to cover the next type of inner class, a local class, so I'll see you in that next video.